There's this really unsettling side to the whole climate change story, isn't there? We rightly focus a lot on extinction, on the species losing out.
We do.
But today, we're looking at the flip side, this paradox, where, well, some species are actually doing better. They're thriving, sometimes ruthlessly.
Exactly. And we're talking specifically about anthropogenic climate change. That just means the really accelerated warming we've caused since the Industrial Revolution.
Right, it's too fast for many ecosystems.
Way too fast. And that speed creates, a kind of power vacuum. Some adaptable species are just stepping right in.
So our mission today is to look at who is thriving, and maybe more importantly, what's the cost? What happens to the existing ecosystems when these winners move in?
It turns out winning can be pretty destructive, too.
And you mentioned speed. The place to really see this happening fast is the Arctic, isn't it?
Oh, absolutely. The Arctic is warming something like 3 times faster than the global average. It's ground zero for these rapid biological shifts.
Okay, let's dive into that. The Arctic. It's like the warming temperatures are just opening the door for species from further south. Let's start with the red fox.
Yeah, the red fox is a classic case. They've got these long legs, big ears, great for losing heat, which was a disadvantage up north.
Used to be too cold for them.
Exactly. That cold tundra was a natural barrier. But over the last, say, 70 years or so, across Europe, Asia, North America, that barrier's just gone.
Warmer temperatures mean their heat-dumping features aren't a problem anymore, so they're moving north.
They are. They're expanding, taking advantage of these new conditions. But here's the downside.
There's always a catch.
Always. The red fox's success means the native Arctic fox gets displaced. Red foxes are bigger, more aggressive.
They just outcompete them.
Completely. For food, for territory. The Arctic fox is being pushed out of its home. It's a direct loss purely because the red fox is winning the climate lottery.
Wow. Okay, so that's one clear winner-loser scenario. Now, moving from the tundra to the boreal forest. White-tailed deer. They're moving north, too.
They are. They're already the most abundant, wild, ungulate, hoofed animal in their range. But historically, extreme cold stopped them.
There was a specific temperature limit, wasn't there? Something about shivering?
Yeah, precisely. Below -7.7 degrees Celsius, they start shivering uncontrollably to stay warm.
Which costs a ton of energy.
A critical amount. If there wasn't enough food around to make up for that energy loss, going further north was just too dangerous. But now, warmer winters mean that risk is, well, it's often gone.
So they push into the boreal forest. Good for them, but you hinted this has a really dark side for the ecosystem.
Oh, it's pretty bad. First off, they are hungry. They eat everything, small plants, young trees. They really change the structure of the forest floor.
Okay, so they're altering the habitat.
And they don't travel alone. Where deer go, wolves often follow.
Right, their main predator.
Exactly. So now you've got more wolves pushing into the boreal zone, putting extra pressure on the native boreal caribou, which are already struggling.
Okay, competition, predation. But wasn't there something else? Something biological they carry. This sounds like where it gets really nasty.
This is where it tips into potential disaster. Yeah. They carry a brainworm parasite.
A brainworm?
Yep. Totally harmless to the deer themselves.
Why?
But for native moose and caribou, it's deadly. Virulently deadly.
Oh, no.
So the deer are basically acting like Trojan horses. They walk into this sensitive ecosystem carrying a biological weapon that the native species have absolutely no defense against.
So climate change lets the deer move north,
right,
and they bring this lethal parasite with them. That's staggering. It's not just about food anymore.
Not at all. It's disease transmission driven by warming. And speaking of species causing problems just by succeeding, beavers.
Ah, nature's engineers. Usually, beaver dams are great, right? Creating ponds, habitats for birds, fish.
Usually, yes. Fantastic ecosystem engineers in most places. But when they move into the Arctic and start building dams there...
It's different. Why?
Because the ponds they create, that standing water, it thaws the permafrost underneath.
The frozen ground.
Yeah, soil that's been frozen solid for thousands of years, trapping ancient carbon. When it thaws, that carbon gets released.
As greenhouse gases.
As potent greenhouse gases, methane and carbon dioxide, bubbling up into the atmosphere. So the beaver, just doing its normal beaver thing,
is actually accelerating climate change.
Locally, and because of the scale, globally too. It's this bizarre feedback loop where their success in this new, warmer environment helps make the environment even warmer.
That is deeply ironic. Thriving in a way that worsens the problem that allowed them to thrive.
Wow. It really makes you think, doesn't it? When does natural adaptation start fueling something unnatural?
Let's shift gears a bit. Look beyond the Arctic itself. Range expansion is happening elsewhere too. The Canada lynx, for example, they seem to be benefiting.
They are, in a way. Lynx need trees for cover when they hunt. As the planet warms, the tree line is creeping northward.
So the forest expands and the lynx follow.
Pretty much. Their range expands with the trees, giving them more room, potentially more prey.
And that's important for them overall, isn't it? Because they haven't been doing so well further south.
That's right. They've really struggled in parts of their historic southern range. I mean, the European lynx vanished from Central Europe way back in the 1850s, so this northern expansion is a kind of lifeline.
Okay, another winner, at least for now. What about armadillos? I read they're on the move too.
Yes, the 9-banded armadillos. Little armored guys, they like it warm and wet, native to the southern U.S., but they've been marching north for, well, over a century now.
A century. That's persistent.
And the projections are pretty startling. If they keep going at this rate, scientists think they could be setting up shop as far north as New York City within a few decades.
New York City.
Yeah.
Armadillos. That really paints a picture of how much distributions can shift when temperature isn't a barrier anymore.
It does. But, not all these northward movers are quite so charismatic.
Which brings us to ticks.
Definitely not charismatic. And they're moving north, too. They are, and fast. Because of rising temperatures, ticks are expanding their range by about 35 to 55 kilometers per year.
That's incredibly fast.
It is. And they're bringing a whole host of tick-borne diseases into areas that never really had to worry about them before.
It's not just Lyme disease we're talking about either, is it? There's something new, or rather, newly spreading.
Exactly. We're seeing the spread of the Lone Star tick, and this one is particularly nasty because it can cause alpha-gal syndrome.
Alpha-gal, what's that?
It's a condition, potentially life-threatening, where you develop a severe allergy to red meat after being bitten by this tick.
An allergy to meat caused by a tick bite.
Yep. A direct and frankly terrifying health consequence of a tiny pest thriving in a warmer world.
That's intense. Specific, localized damage from these winters.
Yeah.
Okay, let's head into the water. It's not just land animals, right? Aquatic life is changing, too.
Definitely. And it's a mixed bag, like on land. Many amphibians, for example, are in deep trouble. But the bullfrog, largest American frog, it's doing great.
Really? While other frogs struggle, what's their secret?
They're just tough,
Yeah.
really resilient. They can handle a wider range of temperatures. They eat basically anything that fits in their mouth.
Flexible diet.
Super flexible. And crucially, their breeding isn't tightly linked to specific temperatures or rainfall amounts like many other frogs. Plus, they seem less bothered by the infectious diseases hitting other amphibians. They're kind of built for chaos.
Built for chaos. I like that. Okay, over in the oceans, specifically the Mediterranean, Black Sea urchins are booming.
They are. They have this double advantage. They tolerate warmer water and more acidic water.
The acidification tolerance is key, isn't it? With oceans absorbing so much CO2.
It's a massive advantage. But their success is bad news for the seafloor. They're super efficient grazers.
They eat everything.
Pretty much. They create these areas called urchin barrens, just bare rock or sand because they've munched all the seaweed and algae.
And the kicker is you can't even eat these ones, right? Unlike some of the urchins.
Exactly. They're completely inedible, so we can't just fish our way out of the problem. They're an ecological dead end, thriving like crazy.
Okay, this is getting a bit bleak.
Right.
Let's talk jellyfish. They're also booming in warmer oceans. Sounds bad, but
Yeah.
is there a twist?
There is, potentially. It's called the jellyfish paradox. Usually, tons of jellyfish means an unhealthy ecosystem, but some research suggests, well, they might actually be helping a bit with the climate crisis.
Helping. How on earth can a jellyfish bloom help?
Okay, so jellyfish eat smaller organisms, like plankton, that have absorbed CO2 from the atmosphere. They incorporate that carbon into their bodies.
Right.
Then, when the jellyfish die and they have short lifespans, they sink. They sink deep into the ocean.
Taking the carbon with them.
Exactly. Locking it away in the deep ocean, far from the surface where it could get back into the atmosphere quickly. They act like these weird gelatinous carbon pumps.
That is genuinely surprising. A biological carbon sink made of jellyfish.
Okay.
That's fascinating. Let's end on maybe a more straightforward positive note. Something about salmon and eagles.
Yes, a nice example of a positive feedback loop. Some Pacific salmon populations seem to be adapting by hatching earlier in the year as waters warm.
Okay, they're adjusting their timing.
And this directly benefits bald eagles.
How so?
The eagles rely heavily on the salmon run for food, especially when raising chicks. Studies show that the earlier the salmon run happens, the more eggs the eagles tend to lay and the more chicks survive.
So the salmon adapt, and the eagles get a boost.
It's a win-win. A little bit of positive synchrony where two species adapt together in a beneficial way, even amidst all the disruptions.
So we've seen quite the range today. Red foxes pushing out Arctic foxes, deer bringing brainworms, beavers thawing permafrost, ticks causing meat allergies. The adaptability is amazing, but the consequences are often severe for others.
And that's the really crucial takeaway, I think. Just because some species are doing well now in these changing conditions doesn't mean they'll survive if the whole ecosystem eventually crashes around them.
Right, individual success doesn't negate the overall risk.
Not at all. The ultimate goal has to be stabilizing the system for everyone, not just cheering for the temporary winners.
Our sources suggest we have the tools, imagination, vision, foresight, and the organized knowledge of science. So thinking about that, and the very specific damages we talked about, like the deer brainworm hitting caribou or the beaver ponds melting permafrost, here's something for you, our listeners, to consider. What specific, maybe localized intervention, using that science or maybe policy, do you think is most critical right now? What could we actually do to help protect those native species struggling against these new climate-boosted invaders?
Yeah, where should that focused effort go?
Mull that over. We'll be back with another deep dive soon.